Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-3. The first day we'll talk about this, we're going to talk about how to factor as kind of a review of some stuff you've done in the past. So it's a night problem, but I think it's a good basic example to start with. With factoring, the goal is, can I turn a trinomial into two binomials? So what that means is we're going to look for a pattern, okay? Some people call it guess and check, but I like to just think of it as common sense. So as a quick demonstration here, let's say I have x plus 4, x plus 2. When you distribute, you get x times x is x squared, x times 2 is 2x, 4 times x is 4x, and then 4 times 2 is 8. So binomial, you distribute it out, you get these four terms, and then you put the 2 in the middle together, and you get 6x plus 8. For this purposes, the goal is, can I take this and turn it into this? So some key things here. The x squared comes from the fact that it has to be x times x. I like to point out the fact that the 8 here came from 2 and 4 multiplied together. So I know that the 12 is what these two numbers have to multiply to. But then the negative 7 in the middle. Well, negative 7, if I look at the 6 down here, that's the fact that 2 and 4 added together gives me 6. So I've got negative 7 in the middle, a positive 12 at the end. I'm going to have two negative numbers. And what multiplies to a positive 12 but adds to a negative 7? It's a negative 3 and negative 4. That's the goal of factoring. And that's what we're going to do on a bunch of these. Now, there's a few other things with factoring. So, for example, here, GCF. Greatest common factor, there's two levels to it. There's the number, and then there's the variables. So if I start off with 5 and 20, the GCF there is 5. 5 can come out of both of those numbers. Then I look at a squared and a. Well, an a can come out of both of them because they have at least one a in each of them. Okay, so my greatest common factor is 5a. When I factor that, I like to say this as whatever's left inside the parentheses needs to be able to, if I were to distribute this back out, it would go back to this. So if I look at that, 5a times what gives me 5a squared? That would be an a. 5a times what gives me a negative 20a? That'll be a negative 4. And again, if you want to double check, this times this and this times this, that should get back to that factoring. That's all GCF factoring is. Now, that helps if you do that as a first step if you can. So for example, this one. If I want to factor this, I got these three right here for the numbers. They all have a 2 as a GCF. I can take a 2 out to the front. When I do that, I'm going to have x squared. 2 times a negative 6x will give me back to a negative 12x. And then 2 times 9 will give me back to 18. This actually has its own special pattern, but I'm still going to focus on this idea. X squared comes from x and x. Positive 9 over here. That means these two are numbers that multiply to 9. And I got a negative 6 in the middle. So negatives has to go here. The only thing that multiplies to a positive 9 but adds to a negative 6 is negative 3 and negative 3. That will actually go to, I could rewrite it this way if I wanted to, since it's x minus 3 are matching, put them together with an exponent. That's an option if I wanted to. Okay, so this was actually the, what was it? This is a perfect square. This is actually x minus 3 squared like this, has its own special pattern. Okay, so if I look at something like this, let's say I have x plus y squared, that always multiplies to x squared plus 2xy plus y squared. Okay, right? Yeah. So that's what, so if you have something that has that kind of a pattern, which is what this is right here, it would factor into this. Or I should say in this case, x minus y squared, which is going to be x squared minus 2xy plus y squared. And that's what I technically have here. This is the pattern here. If you recognize that, it's a little bit of a shortcut, but just go with this option. Just still do the common sense idea. This has its own special pattern. Y squared minus 36 is called the difference of two squares. Now, I'm going to rewrite this as having 0y in the middle, because that's going to still help my common sense check. We know it has to be a y and a y. We know that's a negative number here, so this is a little bit different. That means I have to have one positive sign and one negative sign. I have 0 in the middle. So I'm thinking what multiplies to a negative 36, but adds to 0. So if I do that, it's got to be a positive 6 and a negative 6. This is a special pattern too, because it's called the difference of two squares. So if I say x squared minus b squared will always factor into a plus b, a minus b. And I just realized I said x squared and y squared. A squared minus b squared, that's the difference of two perfect squares, will always factor into this. So y squared turns into y and y. That's what these are. The negative 36 turns into 1 positive, 1 negative 6, because it's like the square root of 36. Okay. All right. Factor these trinomials. This one's a little different. First thing, always check to see if there's a common factor, kind of like when I did the 2 earlier. This case, I don't. 3, 11, and 4, s squared, s, and then there's no s. There's no common factors here. Okay. So I still want to think of it in terms of what could go in where. So list the factors, the lead coefficient 3 and the constant 4. So for 3, there's only one possibility. It's got to be 3 times 1. As for 4, I could have 2 possibilities. I got 1 times 4 or 2 times 2. So we are going to put them into this idea still. We know it's going to be blank, 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 blank. I think that's probably what the template part was for. But it should not be x's. I don't know why the x's are there. It makes it look like multiplication. Okay. So because it's 3s squared, it has to be a 3s and an s. There's the only way we can work that. But as for this other one, we got a few possibilities because we can either fill out the other one. And I should point this out. I've got a negative number here. So that means it's got to be 1 positive, 1 negative. And I need to end up with a negative 11 in the middle somehow. This is full on guessing and checking. So if I put in, let's say, negative 4 here and a positive 1, that's a possibility. Or I could put a negative 2 and a positive 2. Or I could put in positive 2, negative 2. Or I could put in positive 4, negative 1. There's a bunch of things I can do with both the positive and negatives. Okay. So unfortunately, with guess and check, you might have to do a few of these. I think I know which one it is, just because I think the only way for me to get to a negative 11 in the middle is if I put a negative 4 here and a positive 1 here. That's my first guess that I kind of use a little bit more common sense with. So to make sure I check it, I'm going to go ahead and multiply this out. So I got 3s times s is 3s squared. 3s times a negative 4 is a negative 12s. 1 times s is a positive 1s. 1 times a negative 4 is a negative 4. So 3s squared minus 11s minus 4. That's what I started with. So my first guess was correct. But if you put in different numbers in there, like say you did 2 and 2, check it, doesn't work, go back and try again. Okay, that's guess and check. So my answer here is this one. I'm going to show a slightly different method on this one, because in my opinion, sometimes it's a little bit more efficient to do something different. And it's called the AC method. So we're going to start with this. You're going to take your A value and the C value and multiply them together. So in this case, it's 6 times a negative 4, which gives me a negative 24. Well, then, remember some of the patterns I did before. I need to figure out two numbers that multiply negative 24, but add to a negative 5. I still want to add to the middle number. Okay, so I got to come up with two numbers that do that. So that should be 8 and 3. It'll be a negative 8 and a positive 3. Those two are important because that can split up my middle term. So now it looks like this. I've turned 3 terms into 4 terms. Remember from before when we did our distribution, we distribute 2 binomials. We start off with 4 terms. We put them together, we get 3 terms. I can factor this by looking at 2 sets of 2 now. Okay, it's called factor by grouping. So if I look at 6x squared minus 8x, we can look at what is a common factor of just this. So I can take out 2x. So I'm left with a 3x minus 4x. Then I do the same thing here with this group of 2. Well, 3x and negative 4, they have a 1 in common. So I'm going to put a plot plus 1 and just rewrite it as 3x minus 4. The key here is these two, whoops, that's supposed to be a 4. Okay, key here is these match up. Since they match up, we can do this. We're basically factoring out 3x minus 4 from everything else I'm gonna be left with 2x and plus 1. This is the factor by grouping method, and it's gonna start off with a times c. I like this way because sometimes it's a little bit longer, but you can always get to the correct answer without having to do any guessing. Okay. We got one more example here. I'll just do guessing, or not guessing check, but I'll do the one more time with I'll do this as guessing check. Again, I'll use a more common sense idea. For me to have 5x squared, has to be a 5x and an x, no matter what. That's the only possibility. But with 14, I can have 1 and 14 or 2 and 7. So 1 times 14, 2 times 7. Thankfully, everything's positive. So I need to make sure I put stuff in a place so that I can get a 37 in the middle. Well, I remember 5 times 7 gives me 35. So I bet there's going to be a plus 7 here and a plus 2 here. Quick check. 5x squared, 35x, and 2x makes 37x, positive 14. So guess and check if you have a good feel for it. Super quick and easy. AC method, if you need to, do that to help yourself on that one. All right, that's it for 4-3 day 1. We'll come back to how this is useful for our solving in our next lesson. So take care, everybody.